Hello, and welcome to the lecture on the properties of matter, chemical. So we're going to be talking in this lecture about the chemical properties of matter. These are just a couple of examples of chemical changes that could occur with substances. This lecture is designed to go along with the companion note guide. It looks just like this. You're going to want to make sure that your name is at the top, and we will dive in. We're going to begin with the definition of chemical properties. And so, chemical properties are the tendency of a substance to transform into another substance. So as you are watching this video, feel free to pause at any point. I'm going to be probably moving faster than you are able to write, and so if you need to write down definitions, feel free to pause the video at any time. So chemical properties are the tendency of a substance to transform into another substance. Next, chemical change definition would be atoms that rearrange and switch partners. And we have a couple of examples here. So, and you don't have to write this down, but you have to fill in some blanks. One example is from that previous slide. Iron. If you think about iron like forming a chain, or iron the metal making up some type of component of something, if iron atoms combine with oxygen atoms, you end up with iron rusting. So here is the chemical equation for that happening. You take iron, Fe, plus oxygen, O, you end up with a new substance, iron oxide or rust. Okay, completely rearrange and switch partners. Another example would be grape juice, okay, which you take sugar molecules, shown here. You combine them with some bacteria that does some fermentation, and you can turn those sugar molecules into alcohol molecules. Okay, those are chemical changes where the atoms are actually rearranging and switching partners and making a completely new substance. So you want to make sure that you go ahead and fill in the blanks for iron plus oxygen and what it equals, right? Rust or iron oxide, and then grape juice rearranging its sugar molecules to make alcohol molecules. So grape juice to wine. Now let's kind of summarize the changes here. So in your blank of chemical change, when there's a chemical change, it means that there is a new chemical formed, right? Those atoms are rearranging, switching partners, and you're having a new chemical or a new molecule made. If you contrast that to physical change just means that there might be new attributes, but nothing new is formed. So if you think about water changing phases, right? So from solid, liquid to gas, nothing new is formed. The molecules aren't rearranging. They're just changing their form. All right, there's no new chemicals formed. Why is it hard to tell the difference? Because many times there's a change in appearance for both chemical and physical. And we're going to talk about the best way to differentiate or to tell a difference between a chemical change and a physical change on the next slide. So make sure that you have filled out the difference between chemical change, right, a new chemical change, physical change, and why it is hard to tell the difference. That is right here on your note guide. Okay, next we're going to talk about an acronym that we call EPOCH. Technically pronounced epoch probably, but we're going to say EPOCH so we remember that C and H are separate things. So EPOCH is an acronym, which just means that each letter stands for a different word. It stands for evidence that a chemical change has occurred. So, the first E, effervescence. Okay, so E on your note guide, right here, type in the word effervescence. And feel free to pause again if you need time. So effervescence is bubbling, right, or giving off gas. So if you ever have seen Alka-Seltzer dropped into water, that forms carbon dioxide. It bubbles a lot, right? that is effervescence. Or if you open a can of Coke, the bubbles coming out of it, effervescence. Okay? Any type of bubbles if something is added. P stands for precipitate. So precipitate is a solid crystal that is formed when two chemicals are added together. Okay. There's a spot on your note guide for pictures. We're going to go through the pictures one at a time, but I want you to write down the definitions first. So precipitate, solid crystals form. O stands for odor. Okay, so if you detect an odor, if you add two chemicals and a new smell is present, that could also be a sign that a chemical change has occurred. So O stands for odor. C in epoch stands for color change. So if you happen to add, let's say, two clear liquids together and they turn into, like down here in the corner, a blue or a red or a yellow, color change with two different chemicals sometimes can be evidence that a chemical change has occurred. And then finally, H stands for heat. So if you feel heat, right, either hot or cold, right, remember that heat is, or cold is just the absence of heat, that can also be evidence that a chemical reaction or a chemical change has occurred. Okay, so now we can look at some pictures. I want you to draw this in the window provided, right? So you should have E, effervescence, bubbles, fizzing, and then in this note portion here, you're going to be drawing a picture of what that looks like. Here is an example, right? You could be adding, let's say this is probably acetic acid and baking soda, or sodium bicarbonate. You add the two, there is bubbles forming, that is effervescence. Okay, so you want to pause the video at this point and draw some bubbles forming, okay, in a beaker or however you want to do it. And then when you're done with that, you want to draw a picture of a precipitate forming, so solid crystals forming after two different chemicals are added to each other. Remember, these are chemical changes, right? Something is switching partners, rearranging, creating something new, and so you end up with crystals formed, right? And this is kind of what it looks like. Next, odor, right? You can simply draw a nose with maybe some fumes, however you want to depict that some type of smell, right? Maybe a change of smell is detected. That can also be a evidence of a chemical change. Color, let's say you go from clear, you add something and it turns blue. That could also be a chemical change, some type of rearranging, switching partners, making something new. And finally, a picture of heat, right? So maybe some flames given off, or potentially, you could also draw something getting colder or an absence of heat. Okay, that can also be evidence that a chemical change has occurred. So now you should have pictures next to each of epoch, each of these: effervescence, precipitate, odor, color change, and heat. And they should be all filled in here. Next, we're going to turn our page over and we're going to review, right? Because we've spent a fair amount of time talking about physical changes, right? We're going to review what those are, and then we're going to talk a little bit about chemical changes, and then we'll get into some final definitions. So just to review, okay, and you're going to want to write this down with some fill in the blank. So a physical change, remember, we can alter a substance, but we don't make anything new. Okay, and so in the fill in the blank, you're going to want to fill in alter a substance, but to not make anything new or something new. Okay, and so some examples of physical changes, right, going back to our physical change lecture, would be a change in state. Okay, think about dry ice sublimating or water boiling, freezing, melting. Those are physical changes. Those we are not making anything new. They're just water or carbon dioxide changing form. Okay, so you want to fill in that changing state, and then you can write in boiling, melting, freezing, etc. Okay. Next, we can also have physical changes where you just break something or bend or crush or mix. You're still not making anything new. You are just simply changing its size or shape. So substance is not changed, right? Just the size or the shape of the substance. So chopping wood or cutting an apple are examples of those. So those are our typical physical changes, right? You're not making anything new. You're just maybe changing its appearance. Contrast that with chemical changes, right? So on the right side of your notes, you want to fill in, you are making something new. Those atoms are forming new and different molecules, completely different from what there was before. Okay, so make something new. And then down here, you're going to want to write in just that acronym, EPOCH, right? And as a review, right, EPOCH stands for those things that we just talked about. The effervescence, the bubbles, the precipitate that gets formed, odor, color change, heat. If any one of these things happen, that is good evidence that you have just made something new. You've had a rearrangement of atoms into new molecules. So feel free to pause, write EPOCH down, review physical changes. Finally, let us break down the difference between molecules and compounds. Okay, so now we're on our last section, and then we'll finally talk about the definition of chemical formula. We will be doing a lab that it's going to help a lot to understand some of the chemical formulas that will be in the lab. So a molecule, as this should be a review, simply more than one atom bonded to each other. Okay, so we have a molecule, which we've defined before, but examples are hydrogen, H2, oxygen, O2. Remember, those are two atoms bonded together of oxygen. H2O, another molecule. H2SO4 is sulfuric acid. H2O2 is hydrogen peroxide, which I'm sure you've heard of before. All examples of molecules, okay, which we've talked about. Turns out that there is another type of molecule, okay, and they are compounds. And so the difference between a compound and a molecule is that compounds are molecules, but just with atoms of different elements attached to one another. So we have an example given here, our table salt, right? If you take sodium and chlorine, which are two different atoms, combine them together, you end up with sodium chloride, just table salt. Okay, so take a moment and write this definition down in your notes. Molecules with atoms of different elements. So a compound is a molecule, but not all molecules are compounds. Okay, so for a compound to be something, it has to have two different elements, right? So in this case, sodium and chloride. Some other examples, which you can draw here in your examples of compound, are things like HCl, right? Hydrogen and chlorine, that's hydrochloric acid. Okay, or finally, sodium and oxygen and hydrogen, it's called sodium hydroxide. It's a very powerful base. Okay, so those are two, in this case, three different elements all combined together. You can have many, many more. But a compound, different atoms of different elements. And then finally, we'll talk about chemical formula. So chemical formula just simply represents a molecular compound. So when you look at your NaCl, or your sodium chloride salt, this technically is a chemical formula. Okay, water, its chemical formula, H2O, we can call it dihydrogen monoxide, right, or water. H2O2, I mentioned before, we can call it either dihydrogen dioxide or hydrogen peroxide. Okay, these are naming the molecules, right? And there's different ways of doing it. But di stands for two, right? Mono stands for one. Finally, manganese dioxide. This is manganese, 2 oxygen. So you want to make sure you double check that you have all your notes filled out. And then when you're complete, you've done the lecture. Thank you for listening.